Hello, in this video I'm going to do an example of a derivation with a subderivation. So here we are going to show that this is a theorem. Let's pull this apart first to see what we're actually working with. So we've got this conditional, okay? This is the antecedent and that's the consequent. This is itself a conditional. There's the antecedent, and here's the consequent. So what we're showing then is if this is true, then if this is true, then also that is true. So this is like showing an argument if it had this as a premise and this as a premise and this as a conclusion, except it's all one sentence. So let's see how we would do a derivation of this. So show the conclusion. Assume CD is always our first step. Next step would be to enter the premises. There are no premises. There's nothing to be done. After we enter the premises, our next step is to apply inference rules. We would like to apply modus ponens or modus tollens. We don't have P, we can't apply modus ponens to line 2. We don't have not Q, we can't apply modus tollens to line 2. We can't apply our inference rules fruitfully. We're stuck. And in particular, the derivation is stuck. We're stuck because the derivation is stuck. There's no way to apply inference rules in a way that's going to move the derivation forward. Of course, we could apply double negation, and we could adjoin these two, but this is all useless and pointless. There's no way we can apply inference rules that will move the derivation forward. That means we want to do a subderivation. So there are a couple ways to get a subderivation started. You can actually just type show, or you can type Control-Shift-S. That's Control-Shift-S. And then you put in here what you want. So you could come up here and you could copy this using Control-C like that. And why would we do that? Well, look, if we finish this somehow or other, if we box and cancel line 3, hey, line 3 is a consequent of line 1, and so we'll be able to say 3 CD. So once we complete line 3, once we box and cancel line 3, we can immediately complete the main derivation because we'll cite 3 for conditional derivation because 3 is the consequent of line 1. That's why we would want to do this particular subderivation, right? There are always two questions with a subderivation. One is, am I stuck? Second is, what should I do? And we want to do something that will help us with complete the derivation, and the best thing that will help us complete the derivation is something that will let us box and cancel the derivation. Now, we can actually, however, just like we have this show conc for show conclusion command, we have a show cons for show consequent command, and that actually writes out that subderivation for us, that line. So that's quite handy. Okay, so we'll go ahead and say assume CD, because we have a new line. Okay, now there are no premises to enter, but we want to look for inference rule applications. And we look around and we say, well, okay, we got a new line, we got line 4. Well, line 4, for modus ponens and modus tollens with line 2, we needed P or not Q. Line 4 doesn't give us P, and line 4 doesn't give us not Q, so it doesn't let us do MP or MT with line 2. Can we do MP or MT with line 4? No, because we would need Q or not R. So we can't do MP or MT with line 4. So the derivation is again stuck. And when a derivation is stuck, what should we do? We should do a subderivation. Okay, we want to do a subderivation that will help us complete the derivation we're working on. So we want to do a subderivation that will help us complete line 3. That will help us box and cancel line 3. What will box and cancel line 3? Well, if we get its consequent, if we get if P then R, then we can box and cancel line 3. So multiple subderivations, no problem. You can write as many show lines as you want. So we'll say assume CD here. And now we want to see, can we use this line? And in fact, now we can. We wanted P for modus ponens with line 2. We just got P, so we'll say 2, 6 modus ponens. Okay, can we use Q? Yes, we can use Q with line 4. We can do another round of modus ponens, 4, 7 modus ponens. That gives us R. Can we do anything with R? Yes, we can box and cancel line 5. 8 is the consequent of line 5, so we can say 8 CD, and we box and cancel line 5. Now, this stuff here is now boxed and we can't use it anymore. We don't want to, but it relies on this assumption. And it was fine to make this assumption when we were trying to show if P then R, but now that we've shown if P then R, we don't want to use that assumption anymore, and we don't want to rely on reasoning that involved that assumption anymore, so we box this to indicate that. Now, not only that, but if you see this little triangle here, if you click it, that actually hides that reasoning. And that's good to do because we're not going to use that reasoning anymore. We can't. It's a box. We can't touch it. So we get rid of it. We don't have to think about it anymore. So now we've done line 5, and we boxed and canceled line 5. Now, once you complete a subderivation, you want to use that line right away. You did the subderivation for a reason because that line was going to help you. Let the line help you. So right away, use it. So what are we going to do with line 5? Well, line 5 is the consequent of line 3, and that means we can box and cancel line 3 with CD. And if we forgot that, if we look here, we see it says show cons, and that tells us why we did this. It's not a justification, because it doesn't need a justification, but it does remind us of what our goal was, why we thought it would be helpful. And we thought, okay, this is the consequent, right? Cons for consequent. This is the consequent of what we were previously trying to show. So we say 5 CD, and we're good to go. And again, we can close this one up too, and we're going to do something with 3. What? Well, we look over here, it says that show cons, so this is the consequent of something else we were trying to show, so we can again say 3 CD, because this is the consequent of that, and we are done. So there is an example of our subderivations in action. We show the conclusion, we make an assumption, the derivation is stuck, so we do a subderivation, and we do this show cons subderivation. We make a new assumption, always make a new assumption. The derivation is still stuck, unfortunately, so we do another subderivation, and we do another show cons subderivation. We make another assumption, and now with these 3 assumptions, we have enough material to complete the derivation. So, there you go. That's an example of a derivation with subderivations. I will do another one, which is going to have some other comments, so do please watch that one as well.